Hey everyone! In today's video, we're going to be solving the work of going against friction. I've picked a holiday example because I'm feeling very merry today. If you're doing this in the summer or someplace without snow, I hope that you can appreciate my excitement on this end. Let's find the key terms. A reindeer is pulling a sleigh with a mass of 300 kilograms, a distance of 50 kilometers, over a surface with a coefficient of friction of 0.3. How much work did the reindeer do if it pulled the sleigh with a constant velocity the entire journey? So unlike some of our other examples where it was a change in energy, this is one of those times when we are going to be solving work by saying that it's equal to the force applied multiplied by the distance. And keep in mind that your force is going to be in newtons and your distance is going to be in meters, which means that little 50 kilometers up here, we're going to have to convert that into meters. So we're going to take 50 kilometers and we're going to multiply it by 1,000 because that is 50,000 meters. Big trip for our poor little reindeer. The next thing that's important here is that you were told the reindeer went at a constant velocity the entire journey. That means that it pulled exactly against friction the entire time. Now the hint here is that it says a coefficient of friction. So you know that we're going against friction. But because it's not accelerating the sleigh, I'll say this again, because it's not accelerating the sleigh, its force is going to perfectly match friction. So let's see if we can find the friction on this sleigh. Our force of friction is equal to mu times the mass of what we're pulling or pushing multiplied by gravity. So in this case, our force of friction is going to equal mu, our coefficient of friction, which is 0.3. 0.3 isn't too bad. It's a little slippy, not too slippy. Multiplied by the mass of the sleigh, 300, multiplied by gravity, 9.81. And this equals 882.9 newtons. That is the force that the reindeer must exert the entire trip in order to keep this sleigh going. If they went above this number, the sleigh would start accelerating. If they went below this number, the sleigh would coast down until it came to a stop. So they had to have pulled 882.9 newtons the entire time, which is part of the equation for work, because the work equation is the force that was applied the entire trip, 882.9, and I like putting things in brackets because it keeps track, multiplied by the distance, a colossal 50,000 meters. This reindeer was busy, and it is going to equal this magnificent workload of 44,145,000 joules. We could even approximate this. We could approximate this as 44.145 megajoules. Not much of an approximation. I didn't want to round that too much there. Megajoules. That is a ton of work for this little reindeer. But this calculation applies to all situations when you're pushing against friction. All you need to do is solve the force of friction and multiply it by the distance that you either had to push or pull it. Keep in mind, watch for that term, constant velocity. That is key to one of these questions, because if it's speeding up or slowing down, that is not one of these questions. That is something entirely different. Good luck with working on these. This is solving the work of going against friction. And if you have any questions at all, please leave them in the comments down below.